Hey guys, problem 2 for this homework assignment is this, and I think the easiest way of solving this one is to remove the reaction at By, replace this with a point load, and that way you don't have to worry about the overhang that occurs between B and C. Whereas for problem 1, you were using moment area, I think problem 2, it'll be easier to work with, it's easier to use virtual work. Now for virtual work, remember that we're going to end up having 3 systems. We're going to have 2 P systems and 1 Q system. Our original problem is this, right? And these are all length L. I'm going to remove this reaction and replace that with a force. I think that's fairly basic. That's similar to a lot of things we've done so far in this course. I'm going to end up analyzing this system plus this system. This is 2P, this is P, this is By. And this is my P1 system. This is my P2 system. I need a Q system. My Q system will be very similar to my By system. It'll just be 1. And the reason why this is because I'm interested in the deflection at B. I already know what this, I had to find this one already, so why not just make the arrow in the same direction? If I make the arrow in the same direction, then my moment diagram for these two will be almost exactly the same. The only thing different will be that I need to divide my moment diagram by By in order to get the moment diagram for, or I need to set By equal to 1 to get this moment diagram. If I go through and I generate my, let's look at the moment diagrams. The moment diagram for this one will be something like, and this will be positive downward, it'll be something like this. Moment diagram for the blue one will be something like this. Moment diagram for the green one will be something very similar to the black one. It'll be like this. Now, this and this is very simple. I have that table that I can use to get these values, and I won't have any problems with I won't have any problems finding the values I can use. I can either break it up into 2 triangles in order to use 1/3 M1 M3 times L, or I can just leave it as is. I'm sorry, I was trying to find, this is what I was looking for. I can use a triangle times a triangle, or I can do rectangle times a rectangle plus rectangle times a rectangle. Either one of those will give me the same result. This blue and the green is more interesting. I need to break this up into 3 sections. Basically, wherever I have a change in slope in my moment diagram, I'll need to look at a different value. And let me double check here. Actually, that's not true. I can just use a. Yeah, I can go ahead. I thought that I would have to break it up into triangle, triangle, and a trapezoid because of the discontinuities there. But it turns out that I can just go ahead and use this formula. A and C do not need to be equal. In this case, I do need I'm sorry, I should be looking at the blue and the black ones. And the blue and the black, well, not the blue and the green ones, the blue and the black ones. And I will still use this formula. I just need to be careful with how I define A, C, and D. But other than that, everything should be okay. So again, just as a reminder, the general procedure for this type of problem is, this is my QB system. I'm going to find delta B twice. And let me move this up here a little bit. I'm going to find delta B due to 1 plus delta b due to 2 equals 0. The reason why I'm adding these two together is because both of my deflections are assuming that positive is in this direction. I'm using the same Q system for both my P1 and P2. Therefore, my deflections will be in the same direction. I add terms that are in the same direction together, so I put them on the same side of the equation. This is also the same as saying delta B1, the magnitude of this is equal to the magnitude of delta B2. I can do either one of these. I prefer to work with this one when I'm doing virtual work, and I prefer to do this one when I'm using moment area, just because with virtual work I know the direction of the deflection. Okay, so delta B1, let's look at that again here. Delta B1 is going to be equal to this triangle times this triangle. Delta B2 is going to be equal to, this is blue, it's going to be equal to this triangle times this triangle. Now note that these two peaks, this one's positive, the blue one is positive, the black one is negative. I do need to keep track of the signs. The signs will tell me what direction the deflection is going. If I get a positive value for the sign, it means that my deflection is going in the direction of my QB diagram. If I get a negative value for the sign, it means it's going in the opposite direction. With that, I don't think there's anything else that should be too tricky with this problem. I think this is the easiest problem to solve because you don't have to worry about parabolas. And as always, let us know if you have any questions.